everyone. Thank you for joining me. I'm so glad you made that extra effort to ensure that you do well on the test. I suggest that you pause the video and work the problems out before you reveal the answer. I am confident by watching this video and practicing along with it that you're going to definitely increase your chances of getting a high score on the test. Now, one thing I want to make a note of, this video was made with both new and old voiceovers, so the numbering of the problems may not coincide with what you see on the screen in terms of order of 1, 2, 3, and 4. So just disregard that. Other than that, good luck and do your best. In this example, we're going to locate points on the rectangular coordinate system. The coordinate of point A are where? Okay, so to get to A from the point of origin, what we're going to have to do is we're going to have to move over to the right 4. That's my x value, and it's a positive. And we're going to move up 2, that's also a positive. So therefore, the point A is located at 4, 2. In this example, we're going to determine which quadrant a point is located. So recall in the class lectures, I've mentioned to you several times that you should know where a point is located based on their signs, not based on the number. Because if you look at this, it may look intimidating because you see this fraction. But we don't care that it's a fraction. The fact is, the first value is a positive, the second value is a negative. And if you look at the rectangular coordinate system, for a positive, you would go to the right, and for a negative, you would go down. So any coordinate or ordered pair that has a positive and a negative is automatically going to be in quadrant number 4. So know your quadrants based on the signs, not based on the numbers, and that way you don't have to stress if you're given, let's say, a fraction or a decimal or a large number. Just pay attention to your signs and you'll always know where the point is located. In this example, we're going to interpret a line graph. Now, I just want to make a note on the test itself. The only way I can prepare you for interpreting a line graph is to just give you some tips on making sure that you pay attention to your titles. So you pay attention to the x-axis, what it means. Here on the x-axis is referring to the monthly average. And then on the y-axis here, it refers to the number of rig drillings. So pay attention to that, and then look at your points, read the question, and then just answer it based on that. But just because you see this particular example doesn't mean you're going to have this same type of example. It could be any type of question related to that line graph, but just make sure you read all your labels, and that will help you to be able to interpret the data. So let's begin. The question says here that the number of rig drillings decreased by how much from 1982 to 1986. So let's take a look at 1982, the first year we were given. If we follow where the point is located at that year, so it is at 4,000. And at 1986, it is approximately, okay, it's a little bit more than 2,000. So if you have 2,000, then we have 3,000. So what would be in between that mark? Yes, it would be 2,500. So 2,000, then 2,500, then 3,000. So that mark then of 1986 is located at 2,500 because it's the middle point between the 2 points. So then if you want to know how much it decreased by, because we can clearly see that from 1982 to 1986 that there was a decrease. So to see how much it decreased by, all you need to do is subtract the two numbers. So let's go ahead and subtract that 4,000 minus 2,500, and what we're left with there is 1,500, and that is the amount that it decreased by. Scatter diagrams and trends. Describe the trend and relationship, if any, shown in the scatter diagram below. So again, when we have any type of graph or diagrams, we want to always look at our axes or our labels. So here on the x-axis refers to the practice minutes per day, and then on the y-axis we have our free throws that were made, the percentage of it rather. So we can see here that if we look at our cluster of dots here, our data, it looks like our data is moving from left to right in an upward motion. And recall from class lectures that anytime you have a graph or a line that is moving from left to right, that it would have what you call a positive slope. And in this case, it's a positive correlation. So we certainly want to select an answer that includes a positive correlation. So if it's a positive correlation, notice as you move along on the x-axis that the value is going up at 10, 20, 30, 40. The dot, notice the dot is going up. And as we move along the y-axis as well, here 10, 20, 30, 40, notice what's happening also. As you're going up, the dots are also going up. So it's a trend where it looks like as the amount of time spent practicing per minute, per day increases, that your free throws made increases as well. So we want to select the correct choice of B, a positive correlation that as the amount of time spent practicing per day increases, the number of free throws made also increases. This is again, positive correlation. In this example, we're going to determine ordered pair solutions. Determine whether the given ordered pair is a solution for the given equation. So we're given the equation 4x minus 5y equals 8, and we're given the first order pair of 2, 0. So we're going to plug in a 2 for x and a 0 for y. We want to plug it in and see if we're left with a true statement. So on the left side, we're going to go ahead and calculate it. 4 times 2 is 8. And any number multiplied with 0 is going to be 0. So what that leaves you with is 8 on both sides. And that is a true statement that 8 is the same as 8. 8 is equal to 8. So therefore, that's your proof that yes, the ordered pair of 2, 0 is a solution to the given equation. Now let's use that same equation but plug in a different point. We want to see if 3, 1 is a solution. So we're going to plug in a 3 for x and a 1 for y. When we do so, it's going to look like so. Let's go ahead and do the math. On the left side, we have 4 times 3, which is 12, and 5 times 1, which is 5. So that's going to be 12 take away 5. 12 take away 5 is 7, and 7 is not the same as 8 on the other side. That is a false statement. When it leaves you with a false statement, that is your proof that no, that ordered pair is not a solution to the given equation. In this example, we're asked to find the grade of the road shown below. So recall from class lectures, grade is nothing more than the same thing as the slope. The only difference is that you're going to represent your answer as a percent. So let's go ahead and get our fraction first. So recall, slope is about rise over our run. So notice here we have a rise of 2 meters and we have a run of 16 meters. So that's going to give us 2 over 16. Take your calculators out and you're going to do top divided by the bottom. The calculator is going to give it to you in decimal form. From there, you're going to go ahead and turn it into a percent, and recall what you need to do to turn it into a percent. That's correct. It's as simple as just moving 2 decimal places to the right and then place your percent symbol. So let's go ahead and move 2 places to the right. And we're going to place our percent symbol at the end, and that leaves us with 12.5%, which is choice C. Number 7. Determine the slope and y-intercept of the equation 3x minus 6y equals -9. So what is the correct answer? Choice A. Notice the given equation is in standard form. So recall that the equation needs to be in slope-intercept form before determining the slope and the y-intercept. So let's start by rewriting the equation in slope-intercept form. So the first step we need to do is to subtract 3x from each side, then divide by -6, and y equals 1/2 x plus 3 over 2, which confirms the answer choice. In problem number 1, we are asked to use the graph below to find the slope of the line passing through points A and B. The correct answer is C. One method we can use to solve this problem is the slope formula. Recall that if you know any 2 points on a line, you can plug the points into the slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So step 1 is let's identify the 2 points on the line. So where's point A? If you said -2, 3, that is correct. And where's B? That is correct. 1, -4. So now we can go ahead and plug these 2 points into the slope formula. So again, that's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Notice I colored them, the various colors, so that you are able to see how they are plugged into the formula. So once we plug them in, it looks like this. On the top, we have the signs are the same. Keep the sign. We want to add the numbers. That's going to give us -7. On the bottom, we have a double negatives, -2, but with a negative in front of it, it becomes +2. So that's going to give us 1 plus 2, which will give us 3. So our slope then is -7 over 3, which is the same as -7/3 as our slope. Another method to solve this problem is to use the rise over the run. Now recall the slope of the line is the ratio of the vertical change, represented by the rise between the 2 points, and the horizontal change, represented by the run. Now, when you see rise, that means that's a vertical move. To rise is to go up, and to fall is to go down. A run represents a horizontal move. If you run to the positive direction, that produces a positive number. And if you run in the negative direction, that produces a negative number. So it really doesn't matter which point you move from A to B or from B to A. On this particular slide, we're going to move from point B to A. So to move from point B to A, we're going to rise up 7 and run 3 to the left side. So that's going to produce a negative number. So our slope then is 7 over negative 3, which is the same thing as negative 7/3. In this example, we're asked to find the average rate of change. So whenever you see those words, average rate of change, again, that is nothing more than the slope. So in order to find that, all you have to do is to use the slope formula. So let's go ahead and see what that involves. So recall, average rate of change is nothing more than just a slope. So in order to find it, you're going to have to use the slope formula. And recall, the slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Meaning, subtract your y values and place them on top, subtract your x values and place them down below. Now, let's go ahead and identify our 2 points that we want to plug in, because when you're using the slope formula, you're always plugging in 2 points. So here's our first point, 10, 7.5. Our second point is 55, 41.25. So when we plug those in, it's going to look like so. Now we're going to go ahead and subtract the top and the bottom. That's going to give us 33.7 over 45. Go ahead and get your calculators out, and you're going to do 33.7 divided by 45. And what you should get is 0.74 with 8s that run on off your calculator for as long as your window has space for. So what we do is we normally put a bar over the number that repeats itself over and over. But if we were to round this to where it's just 2 decimal places, the fact that this number 8 is greater than 5, it's going to make the next number in front of it 1 more, which is going to give you an answer of B, 0.75 millimeters per second. That is the average rate of change for the data given. In problem number 3, we were asked to determine which equation describes the given graph. So what is the correct answer? Yes, D is the correct answer. First, let's examine the orientation of the line that's graphed. Notice the line rises from left to right, which indicates that it has a positive slope. Now let's use the rise over the run to determine what is the slope. So we're going to go from one point to the other using rise over run. So I'm going to rise up 3 and then run 1 to my next point, which tells me that I have a slope of 3. Also notice that the line crosses the y-axis at -6. So it has a y-intercept of 0, -6. So putting everything together, now you can see why the answer y equals 3x minus 6. Remember, whatever's in front of x is your slope. And the back, you have your y-intercept, which is -6. In problem number 4, we were asked to determine which graph describes the equation y equals -4/3 x minus 1. So what is the correct answer? Choice A. Let's look at the line that we were given. Notice that it has a slope of -4/3. So that means that any line that is not negative, in other words, Any line that is the opposite, that has a positive slope, should automatically be eliminated. So if we look at choice B, you'll notice that choice B moves from left to right in an upward motion, which means that we can eliminate that positive slope because it cannot be the answer. Next, let's look at the Y-intercept. Notice in the back of the slope you see a -1. That's the Y-intercept, which means this is the point at which it touches the Y-axis. So we're looking for a graph that has a negative slope and touches the Y-axis at 0, -1. And the only one that does that is A. Now we can check that using the rise over the run. We can move from one point to another. So let's do that. I'm going to fall down 4 and run 3. And notice it takes me to my line, which means that it verifies that my slope is -4/3. Number 5, determine which equation describes the given graph. So what is the correct answer? Choice A. The graph of y equals -4 is a horizontal line parallel to the x-axis that passes through the y-axis at -4. Number 6, determine which equation describes the given graph. So what is the correct answer? Notice the graph of x equals 2 is a vertical line parallel to the y-axis that passes through the x-axis at 2. Number 8, write an equation of the line passing through the point -3, -2 with slope 3/4. Write your answer in standard form. So what is the correct answer? Choice A. Recall that to write an equation of a line, you will need to know two things. Remember? You need to know the slope, and you need to know a point on the line. Now you will also need to use a formula to create your line. So recall, you can either use the slope-intercept formula or you can use the point-slope formula. So I'm going to show you the solution to both to accommodate your preference. So on the first one, y equals mx plus b, you're going to remove the y and replace it with -2 because that is the y value that you were given. You're going to remove m and replace it with your slope of 3/4. You're going to remove x and replace it with the value you're given of -3. So when you do that, it looks like this. The next thing you need to do is to combine the right side. So 3 times -3 equals -9/4. Next, you're going to add 9/4 to each side. And to do that, you're going to have to add unlike fractions, and that will give you 1/4. So b equals 1/4. So in slope-intercept form, your line would be y equals 3/4 x plus 1/4. Now we will rewrite it in standard form in just a moment. But let's go to those who chose the point-slope formula and see how you were able to plug your points in along with the slope. So recall with this formula that you are only going to plug points into the subpoints formula, not into the x and y that are by themselves. So of the y sub 1, you're going to remove that and replace it with -2. Remove m and replace with 3/4. Remove x sub 1 and replace with -3. So when you do that, it looks like this. Remember, double negatives become positives. Next, on the right side, I'm going to go ahead and do the distributive property, 3/4 times x, and then 3/4 times 3. Last step then is to subtract 2 from each side. And notice I got the same answer when using the slope-intercept formula. So now we're going to turn the page and then rewrite this equation in standard form. So here's our equation. So the first thing we need to do to write this in standard form is to subtract 3/4 x from each side. So notice when we do that, we have it in standard form, but the problem here is that our x value is negative. And recall that in standard form, this value cannot be negative or a fraction. So what we need to do, we can eliminate both the negative and the fraction by simply multiplying everything by -4 so that we can clear the fractions. So when we do that, we see that we wind up with 3x minus 4y equals -1. And that is our equation in standard form. Number 9. Find the slope-intercept form of the equation of the line through the point 2, 7 and parallel to the line 9x minus 4y equals 1. So what is the correct answer? Choice C. So recall that if we want to write a line that is parallel to the one that is given, the first thing we need to do is identify what is the slope of the line that we're given. Recall also that we cannot read it when it is in standard form, so the first thing we need to do is to rewrite it in slope-intercept form. So the first thing to do is to subtract 9x from each side. Next, divide by -4, and y equals 9/4 x minus 1/4, which means that we have a slope of 9/4. So the line that we are to create that's parallel to this given line must also have a slope of 9/4, because recall, parallel lines have the same slope. So step 2, plug in the same slope and the given point into the slope-intercept formula. So recall that the slope we were given is 9/4. The point we were given is 2, 7, and we're going to go ahead and plug that into our slope-intercept form since we're asked to write this equation in slope-intercept form. So I'm going to remove the y and replace it with the y value we were given of 7. I'm going to remove the m and replace it with the given slope of 9/4. I'm going to remove the x and replace it with the given value of 2. Now what we don't know is b. So let's do the math and find out what b is. So we're going to solve for b. The first thing we need to do is multiply 9 times 2, which is 18, so we'll have 18/4. Next step is to subtract 18/4 from each side. Once we do that, we have unlike fractions that we need to combine. So notice the LCD here would be 4. So all we need to do is multiply the top and the bottom of this first fraction by 4 so that we can write equivalent fractions that have the same denominator. So now we have 28/4 minus 18/4, which equals 10 over 4. When we reduce our fraction, we are left with 5 halves. So putting everything together, our line is y equals 9/4 x plus 5 over 2. And this line is parallel to the line that we were given because, again, parallel lines have the same slope. Number 10. Find the slope-intercept form of the equation of the line through the point 2, 7 and is perpendicular to the given line 9x minus 4y equals 1. Now this is really just the second part of the previous question. We're using the same line and we're also using the same given point. But this time we want to write a line that is perpendicular to the one that is given. So recall from previous problem that the given slope was 9/4. So to write a slope that is perpendicular to that, remember perpendicular slopes are negative reciprocals, meaning opposite and flipped. So the perpendicular slope then would be a negative, and also when you flip the fraction it would be 4/9. So negative 4/9 is our perpendicular slope. So we're going to use the point that we were given and go ahead and plug it in. We're going to remove y and replace with given value of 7, remove m and replace with the perpendicular slope of negative 4/9, remove x and replace with given value of 2. So when we do that, remember we want to solve for b, so I have to multiply negative 4 times 2, which is going to give me negative 8/9. Next, I need to add 8/9 to each side. And when I do that, I have to just simply add those two. Since they have the same signs, we can just put them together and rewrite them in improper form. And the way you do that is whole number times the denominator plus the numerator. So that would be 7 times 9 is 63. And 63 plus 8 gives me 71. Keep the denominator of 9. So my line is y equals negative 4/9 x plus 71 over 9. And that is the line that is perpendicular to the line that is given. Okay, we got 10 problems done. You still with me? All right, let's keep going. If f of x equals x squared plus 2x plus 1, find f of negative 4. So what is the answer? Choice B. So this function notation here is nothing more than just evaluating function, plugging in some number to see what you get out, input, output sort of thing. So we're given x squared plus 2x plus 1. That means that we're going to remove all the x's and replace them with negative 4 to see what we get out. So just using the order of operation, we're going to start with a negative 4 squared. So negative 4 times negative 4 is 16. Next we have positive 2 times negative 4, which is negative 8. Bringing everything else down, and just moving from left to right, we have 16 minus 8, which equals 8. And then 8 plus 1 gives me 9. So f of negative 4 equals 9. Number 12. Which of the following is the graph of a function? So what is the correct answer? Choice B. Recall a graph is a function if it passes the vertical line test. The vertical line test states that a relation is a function if and only if no vertical line intersects the graph of the relation at more than one point. So it cannot touch in no more than one point. So let's draw a vertical line through these graphs to see how many times that the line intersects the graph. Notice B is the only line that passes the vertical line test. Number 13, identify the domain and range of the following graph. So recall that the domain refers to all of your x values or your input values, and your range are your y values or your output values. So when you want to determine the domain, you want to know what are all the x values that have a corresponding y value. And when you're asked to find the range, you want to know what are all the y values that have a corresponding x value. So to put that in plain English, let's start with the domain. I simply want to know how much does this graph extend over the x-axis or the x values. So notice here that the values along the x-axis begin at -4 and they extend to infinity, to positive infinity. So our domain then would be from -4, including 4, and it extends all the way to positive infinity. Now looking at the range is our y values, and we want to know how much this graph extends on the y-axis. Now the fact that this parabola is on its side and it has arrows on both ends, it basically tells us that for the range, it extends from negative infinity all the way to positive infinity. In this example, we're going to evaluate the graph of a function. So the graph of f of x is shown below. Find f of -5. So recall with functions, you have an input and you have an output. And whatever value you see in between the parentheses when they ask you to evaluate, that's your x value. What you get out is going to be your y value. So we already know of our ordered pair, it has a -5 for x. So now let's see what our y, our output is. To do that, on the rectangular coordinate system, since we know x is -5, we're going to go over -5, and to actually get on the graph, we need to go down. And anytime you go down, that's a negative. So to get there, we're going to go down 4. That takes us on the graph, which means that the ordered pair that's associated with an x value of -5 has an y output value of -4. So therefore, f of -5 equals -4. In this example, we're going to determine ordered pair solutions for linear inequalities. So here we're asked to determine whether the given ordered pair is a solution for the given linear inequality. So on the first inequality we're asked to plug in the ordered pair 0, 0. So let's go ahead and plug in a 0 for x and a 0 for y. And what we're left with is a 0 on the left side and a 5 on the right side. Let's go ahead and read this statement and see if it's true. This is saying that 0 is greater than 5. That's not true. Let's see if the other part of it is true. 0 is equal to 5. That's not true either. And since neither is true, the statement is a false statement. So therefore, the ordered pair 0, 0 is not a solution to that linear inequality. Let's do the second example. Here we're given a totally different linear inequality, and we're also given a different ordered pair. We're going to this time plug in a -1 for x and a -2 for y. When we plug those in, it's going to look like so. Remember, double negatives become positives, -1, but the negative in front of it becomes +1. Here we have multiplied together 2 times -2, which is -4. So you're going to have -4 up front, and you're going to have +1 there. Combining a -4 plus 1 is going to give me a -3. If we read that statement, -3, it is less than 7. That's a true statement. So therefore, that means that the ordered pair of -1, -2, it is a solution to the given linear inequality. Number 16, graph the linear inequality. So here we're given a linear inequality. Now the first step we need to do is go ahead and graph the line. So one of the best methods to use when the line is in standard form is to graph using the x and y intercepts. And that's where you're going to let x be 0 and solve for y, and then vice versa, do the let y be 0 and solve for x. So let's go ahead and begin. I'm going to let x be 0. When I let x be 0 and solve for y, I can see that what I have left is -y equals 3. Remember, when your variable is negative that you're solving for, you have to either multiply or divide by -1 so that you can make that variable a positive. So your answer winds up being the opposite, so y equals -3. So next we're going to leave x alone. This time we're going to let y be 0. So we're going to remove the y and replace it with 0 and do the math and solve for x. So what we have on the left side is 3x, and on the right side we have 3. Next step to solving this equation is to divide by 3, and x equals 1. So we have two ordered pairs. Remember, you only need 2 points to plot a line. So we can go ahead and get ready to draw a line. And what kind of line will we be drawing? Is that a solid line or a dashed line? Well, if you look at the inequality symbol in the original problem, you have a less than symbol, which means that we're going to draw our line using a dashed line. So let's go ahead and get our line. The first point is located at 0 and down 3. The other point over 1 and stay at 0. Line your ruler up and draw your dashed line. Our next step is to decide whether we're going to shade in the left side of that line or whether we're going to shade in the right side of the line. Now, there are several methods that you can use to determine that. I'm going to simply use the method of leaving the equation the way it is and use the test point of 0, 0 to determine. So here's our original equation. I'm going to use the test point 0, 0 to decide or to determine which side I'm going to shade. So remember, point 0, 0 is in the center or the origin of our coordinate grid. So what you're going to do is you're going to plug 0 for x and 0 for y into your original formula, original equation. And if you get a true statement, then that means that you would color on the side where that test point is located. And then if you get a false, it means that you're going to shade in the opposite side of that test point. So let's go ahead and plug in those test points. So I'm going to remove the x and replace it with 0, remove the y and replace it with 0. So what I'm left with, you notice that the left side is completely zeroed out. So what I have is 0 is less than 3. Now that is a true statement, and since that statement is true, that means the area in the test point area, which is the left side, is the side that I would shade, because you are always to shade the true side. So I could go ahead and color that in. Number 17. We're asked to graph these two lines. This is an example of systems of linear inequalities. So you will solve it pretty much the same way you did the previous problem. The only difference is instead of graphing one line, you will graph two lines and then afterwards identify the region where these two lines overlap, because that is where your solution lies. So let's go ahead and graph our first line. Now, since our line is given to us in slope-intercept form, we can graph this line very quickly by using the slope and the y-intercept. So we see here we have a slope of 1/2 and a y-intercept of 0, 3. So let's go ahead and plot that point, 0 and up 3. From that point, I'm going to rise and run to my next point. So that is a rise of 1 and a run of 2. That takes me to my next point. Now I'm ready to line my ruler up and draw a line through those points. Notice that the inequality symbol is a greater than or equal to symbol, which means that when you see that line underneath there, that you're going to draw a solid line. My next step is to determine whether I am going to shade the top portion of this line or the bottom portion. So I'm going to use my test point 0, 0 to see whether which side I'm going to shade. So I can leave the equation just the way it is again and remove the x, remove the y, replace them with 0. When I do that, what I'm left with is 0 is greater than or equal to 3. Now, that is a false statement because 0 is not greater than 3 and 0 is not the same as 3. So therefore, that is a false statement, which means that side of the test point 0, 0, the point of origin, I'm not going to shade that side, but rather the opposite side. All right, so next I want to plot the second line. Did you notice that second line is going to pass through the y-axis at 3? So yes, that is a horizontal line. And what type of line am I going to draw? Is that a solid line or a dashed line? That's correct, because when you have the less than or greater than symbol, you're going to use a dashed line to draw your line. So there we have the line. Next, I want to determine whether I'm going to shade the top part of the line or the bottom portion of the line. So I'm going to use the test point 0, 0 again. So since I don't have an x, I'm just simply going to remove the y, replace it with 0, and read the inequality statement. So 0 is less than 3. That is a true statement, and since that is a true statement, that means that I will shade the bottom half of that region. So in terms of systems of linear inequalities, what you're looking for is you want to identify the region that overlaps. Okay, so you notice here that this region that overlaps is where your solution is, because it is the solution that is common for both inequalities. Number 18. Systems of equations solved by substitution or elimination. So what is the correct answer? Choice B. That is correct. Alright, so you were asked to solve by substitution or elimination, so I'm going to address both methods to make sure that I cover those students who chose to solve by either method. So let's start with substitution method first. For substitution method, recall it's about taking one equation and then solve for x or y, and then plug that equation into the other equation. In terms of which is easiest, if you look at the equation here, you see a variable that's by itself or have a coefficient of 1 or -1. In this first equation, it's this one, and the second equation is this one. Either one is easiest to solve for. So in the first equation, you would solve for y. If you chose the second equation, then you would solve for x. So I'm going to go ahead and choose the second equation and solve for x. So the first step to solving for x is I'm going to add 2y to each side. So now that I have what x is, I'm going to use that and plug it into the other equation. So again, it's about taking one equation and solve for x or y, and then plug it into the other equation. So the first equation, since I haven't used that, I'm going to go ahead and plug this equation into the first equation in place of x. So I'm going to remove the x and replace it with 2y plus 1 because I just solved for x, and x is 2y plus 1. And so now that I have my equation, all I need to do is solve for y. So the first thing I need to do is to use the distributive property and multiply 3 times 2y and then 3 times 1. Next, I want to combine the left side. 6y minus 1y equals 5y plus 3 on the left side, and then negative 7 on the right side. Next step to solving this is to subtract 3 from each side, divide by 5, and y equals negative 2. So now that I have the value for y, all I need to know is what x is. So to find the value for x, I take the y and plug it into either equation in place of y and solve for x. So I'm going to go ahead, and it doesn't matter which equation that you choose. You can choose either one. Actually, you've had 3 equations to work with, the first, the second one, and then you created a third one. If I want, I can even plug it into the third equation that I created. Remember that equation of x equals 2y plus 1? Let's just use that one. If I remove the y and replace it with negative 2, this is what I get. Now my next step is just simply to combine those terms, and I'll know what x is. So on the right side, 2 times negative 2 is negative 4, and negative 4 combined with a 1 is negative 3. So my x value is negative 3. I have both my x and y, so my solution to this system of equation is negative 3 comma negative 2. Continuing on with number 18, solving by elimination method, aka addition method. Now they call this elimination method because in order to solve the system of equations, you're going to have to eliminate either your x variables or eliminate your y variables. And then once you eliminate them, you're going to add the remaining terms. So as far as which one should you eliminate first, well, it's a lot similar to the method that you use to determine the substitution method. You're looking for variables that have a coefficient of 1 or negative 1. So in the first equation, I can eliminate my y's if I like. It would be easiest to do, or it would be easiest to eliminate the x's here. And the reason for that is because when you eliminate them, you are looking to multiply that one variable with a number that would eliminate the other variable. So what I mean is here I'm going to choose to eliminate the x's. So to eliminate the x's here, if I have 3x here, then this needs to be the opposite of 3x. It needs to be negative 3x. And the way I can make this negative 3x is by simply multiplying it by negative 3. But you know the rules of equations. What you do to one, you have to do to every one in that equation. So I have to multiply all terms by negative 3. So I'm going to go ahead and do that. And once I multiply all 3 terms by negative 3 using the distributive property, I'm left with a new equation. And you'll notice here that my x's canceled out. They were eliminated. So when I combine the remaining terms or add the remaining terms, I draw a line, and add the remaining terms, what I'm left with is 5y equals -10. Next step to solving this is to divide by 5, and y equals -2. Now the same as with the other method, once you find one variable, all you have to do is plug it back into either equation to find your second variable or your second number. So we're going to plug y into either one of the equations. It doesn't matter which one that you plug it into. So again, we can plug it into our equation. We can plug it in number 2. So let's plug it in number 2. We're going to remove the y and replace it with -2. When we do that and do the math, we see here -2 times -2 equals +4. Last step to solving for x is to subtract 4 from each side, and x equals -3. So we see here, using the addition, or aka elimination method, we still have the same answer of -3, -2. Number 19. A total of $3,000 is invested, part at 2% simple interest and part at 4%. If the total interest from the two investments is $100, how much is invested at each rate? Okay, so we can use the systems of equation to solve this particular word problem. The first thing we need to do is assign variables. So since we have two different investments, one at 2% and one at 4%, we need two different variables. So let's let x be the investment into the 2% account, and let's let y be the investment in the 4%. Now, the next thing we want to do is set up our equations. The first equation, remember, should involve what was invested, the total amount that was invested. Your next equation, your second equation, should deal with the interest that was involved in these accounts. So let's start with the first equation. We don't know what was invested into the 2%. We don't know the amount also that was invested at 4%, so that's why we're using the variables. But we do know that there was a total of $3,000 that was invested. In fact, that's the very first part of the sentence. So there's our first equation, is the amount of dollars invested. So what we have is x plus y equals 3,000. Again, we don't know what was invested into the 2%. We don't know what was invested at 4%, but we do know there was a total of 3,000 invested. Our second equation deals with the interest. So we know that with the first account, it was invested at a 2% interest. The second account was invested at 4% interest, and we know that between the two of them, it yielded $100. So that's our second equation. So we're going to go ahead, instead of writing it as a percent, we're going to write it as a decimal. So there's our second equation. All right, and if you're wondering how we turn these percents into a decimal, remember, you just simply move the decimal places 2 places to the left and insert the decimal symbol. However, we do still have our equation in two different units here. We have whole numbers and then we have decimals. It would be easiest to solve this equation if they both were whole numbers. So what we can do with equation number 2 is we can simply multiply all these three terms. We can multiply them by 100 to clear these decimals. One other way is to simply just do it manually and move all three numbers 2 places to the right, and then we can get rid of the decimals. So once we clear the decimals, this is the equation we're left with: 2x plus 4y equals 10,000. So now we have our two equations, and we can proceed with using either the substitution method or the elimination method. All right. So now that we have our equations, we can eliminate one of the variables. So let's eliminate x. And to eliminate x, all we need to do is just simply multiply the top equation by -2. So when we do that, the first equation will change. We did not do anything to our second equation. We leave that alone. So now I can go ahead and proceed with draw the line and do my addition. So what I'm left with is 2y equals 4,000. Last step to solving this is to divide by 2 and y equals 2,000. So remember the y value relates to the 4% account, so that means that 2,000 was invested into the 4% account. Now in terms of wondering how do I find what was invested into the 2% account, well, you can use mental math to do that, because if there was a total of $3,000 invested in all, and you invested 2,000 of that into the 4% account, that means the remaining 1,000 was invested into the 2% account. But if you're not able to readily figure that out, remember all you have to do is take this y value and plug it into either equation, and then you'll be able to find your x value. So let's go ahead and do that. Okay, so it looks like our value of y would be easiest to plug into equation number 1. So let's plug it into equation number 1 so we can find out what x is. When we do that, it looks like this. Last step to solving for x is to subtract 2,000 from each side, and x equals 1,000. So as you can see, 1,000 was invested at the 2% interest, and 2,000 was invested at 4%. We can check our solution by simply plugging those values back into the original equation, and you can see that it does check out that this is indeed our solution to this problem. Hello. In this video, we will be solving a word problem modeled by systems of equations. Now, a vendor sells hot dogs and bags of potato chips. Now, one customer buys 5 hot dogs and 4 bags of chips, costing that customer $17. And then another customer comes along and buys 2 hot dogs and 3 bags of potato chips for $9.25. So find the cost of each item. Now the first thing you need to do after reading the problem carefully is to assign variables. So here we have 2 items. We have hot dogs and we have potato chips. So we can let x be the hot dogs, and we can let y be a bag of potato chips. The next thing we're going to do is to set up our system of equations. So write our equations. So translating the first customer, that customer bought 5 hot dogs. So remember, hot dogs is x, so that would be 5x. Plus that customer also bought 4 bags of chips, and remember chips is y, so that's 4y, and that equaled $17. Customer number 2 bought 2 hot dogs, so that's 2x, plus 3 bags of potato chips, that's plus 3y, and that totaled or equaled $9.25. So there are our 2 systems of equations. So now all we have to do is to solve them. So here are our systems of equations. We can solve by substitution or elimination. Let's go ahead and use the elimination method. And we're going to go ahead and choose to eliminate our x's since they're closest to the edge. It may be easiest to access. We're going to go ahead and multiply the top and the bottom of the equations by their opposites of coefficients. So I would multiply the top equation by -2 and multiply the bottom equation by 5. By doing so, we are then able to eliminate our x's. So when we rewrite the equation after we distribute it, it should look like so. We go ahead and draw our line and begin the adding process. We are left with 7x equals 1225. What is the next step to solving this? That's correct. Divide each side by 7 and y equals $1.75. So remember, y is the bag of chips. So our bag of chips costs $1.75. Now, how do we find out the price of our hot dogs? Well, all we have to do is to plug the price of the chips in, which is the value of y, into either equation to find the value of x, which is the hot dogs. So let's go ahead and do that. Okay, continuing on now, to find x, we need to plug in our value of y, the $1.75, into either equation so that we can find x. So let's go ahead and plug it into equation number 1. In this example, we will be modeling linear equations. The information in the chart below shows the salary of a person for the stated years. Model the data with a linear function using the points 1, 24,800 and 3, 26,100. Then use this information to predict the salary for the year 2008. So the first thing we need to do to write our line, and that's exactly what they want us to do here, is to simply write an equation of a line using the information that was given. So the first thing we need to do is to find the slope, because recall that you need to know the slope and a point in order to write a line. So since we don't know our slope, let's go ahead and proceed by using the points we were given to plug into the slope formula. So recall the slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's going to be 26,100 minus 24,800, and on the bottom 3 minus 1. That's going to give me 1,300 over 2. 1,300 divided by 2 is going to give me 650. So now we have our slope. The only thing we need to know is our y-intercept, and lucky for us, that is already given to us in our chart. Recall when you have a 0 in x's place and some number in the y's place, that number is your y-intercept. So when we place that in the back of our slope, our line is y equals 650x plus 23,500. And now we're going to use this line to predict the salary for 2008. Now, if we follow the pattern that we are given in the chart, with 0 being the year of 1990, and continue on from 1991, 92, so forth, all the way to 2008, the number that will coincide with that year would be 18. So all we need to do then is to plug the 18 into our equation. So 650 times 18 plus 23,500. If we do that in the calculator, we will get an output of 35,200. So the salary for the year of 2008 was 35,200. Okay, that's it for this lesson. Thank you for watching Math on PowerPoint tutorials. If you liked this video and found it to be helpful in any way, please like it and subscribe to my channel.